Hello, this is Math2270. Once upon a time, from the College of DuPage, summer in Lascaux, France, frolicking with some lads. The dog ran away from the lads and into a cave that had many chambers. The lads went to fetch the dog and went through many caverns looking for him. Eventually they did find him in a chamber, but they also found pictures painted on the walls. Many pictures painted on the walls. And a fire, presumably left by the painters of those pictures. Closer to home, at the University of Chicago during that same time frame, Willard Libby was doing research for which he won the Nobel Prize. His research involved these two elements, nitrogen and carbon, and an application of the chemistry associated with them. He found that the cosmic ray protons, helium atoms, would strike the nucleus of atoms in the atmosphere, discharging a neutron, which would collide with an abundant element, nitrogen, ejecting a proton, causing this nitrogen to morph into carbon-14 rather than carbon-12. This is radioactive, and this is part of the carbon dioxide that is absorbed by plants in the photosynthesis process, and they discharge oxygen, but people consume and animals consume the plant life, and so this carbon dioxide and this radioactive isotope finds its way into the food cycle. Now the ratio is very slight. It is 1 part per 1.35 times 10 to the 12 in living things. But then it decays, but it decays very slowly. So we have a problem. How long ago did the painters live that we want to have a solution? So we derive a mathematical model, turn it into a math problem, solve the math problem, and then reflect the math problem back. This is a process we will do over and over in this course. And so that was the problem, and that was the solution we're seeking to have. So now we're going to do some math. If we let y as a function of time be the level of carbon-14 at time t, then the rate of change with respect to time of carbon-14 is going to be a constant times the amount of carbon-14 that is there. This is a logical conjecture, and this is the derivative that you know and love. Now we're going to introduce a technique called separation of variables. I'm going to divide both sides by y and multiply both sides by dt, and I get this expression. Now the left-hand side is just a function of y, and the right-hand side is just a function of t. So we can integrate both sides, realizing those are dummy variables. So here we'll get the natural logarithm of y. Now the amount of carbon-14 is always going to be positive, so I don't have to worry about the absolute value, is equal to, and this becomes kt plus a constant of integration. Now I realize that what I will want to do is exponentiate both sides. So e to the ln y will be y, and this is e to the right-hand side, but that's the same thing as multiplying e to the c, which that is some constant, times e to the kt. And if you think about what happens when t equals 0, that has to be the initial amount that was there at the beginning, because if you put t to be 0, this becomes 1. Okay, so what we have is the solution of that then is going to look like y of t is equal to n0, the amount that was there at the beginning, the concentration, times e to the kt. Okay, so it is known that the half-life of carbon-14 is around 5,700 years. In fact, I am using 5,730 here in my example. So we can say, oh, half of it will be there after 5,730 years. So then we can solve this for k. If we solve it for k, we will find that k is equal to this number. And we in fact then can say, oh, if we measure the concentration that was in the ash, which was this number, and solve for t, we find that the ash is 1,506.25 and change years old. So, the cave paintings were approximately that old at the time of the test. Now, there are many applications of this, including understanding novelty t-shirts. Now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. God bless.